There was a time when the earth looked nothing like it does today. No forests of oak or pine, no fields of grass, no flowers stretching toward the sun. Instead, the land was quiet, raw, and almost alien. And yet, even in that silence, life had already begun to take hold. Some of the oldest plants on Earth were slowly spreading across barren ground, transforming rock into soil and shaping the future of the planet in ways that would echo for billions of years. But many of these pioneers, the very organisms that helped make Earth habitable, did not survive. They disappeared, and in some cases, they vanished abruptly, leaving behind only fragments of clues locked in stone. To understand why some of Earth's oldest plants suddenly died out, it helps to begin at the very start of plant life itself. Long before trees and flowers, the earliest plant-like organisms emerged in the oceans. These were not plants in the way they are known today, but simple photosynthetic organisms, including ancient cyanobacteria. These microscopic life forms used sunlight to convert carbon dioxide into energy, releasing oxygen as a byproduct. Over immense stretches of time, they transformed the atmosphere, gradually increasing oxygen levels in what is often called the Great Oxygenation Event. For many organisms at the time, oxygen was not a gift, it was a toxin. Entire ecosystems collapsed as oxygen levels rose. This was one of the earliest examples of life altering the environment so drastically that it triggered widespread extinction. While cyanobacteria themselves continued to thrive, other early life forms disappeared, unable to adapt to the new conditions. This pattern, life changing the world and in doing so reshaping its own fate, would repeat again and again throughout the history of plants. Eventually, some descendants of these early photosynthetic organisms began to colonize land. This transition, which likely began over 470 million years ago during the Ordovician period, marked a turning point in Earth's history. The first land plants were small and simple, resembling modern mosses and liverworts. They clung close to the ground, lacking roots, stems, or vascular systems to transport water efficiently. Still, their impact was enormous. By breaking down rock and contributing organic matter, they helped create the first true soils. Yet even these early pioneers faced challenges that would shape their survival. Life on land meant exposure to ultraviolet radiation, desiccation, and fluctuating temperatures. The success of these plants depended on delicate balances in climate and environment. When those balances shifted, entire groups could disappear. As time progressed into the Silurian and Devonian periods, plants began to evolve more complex structures. Vascular tissues developed, allowing water and nutrients to move internally. This innovation gave rise to the first true forests. Among the most remarkable of these early plants were species like Cooksonia, one of the earliest known vascular plants, and later towering forms such as Archaeopteris, which resembled a modern tree in many ways. These ancient forests were unlike anything seen today. There were no flowering plants, no grasses, and no familiar trees. Instead, the landscape was dominated by giant ferns, horsetails, and lycophytes. Some of these plants grew to extraordinary sizes, forming dense, humid forests that stretched across vast regions. They played a crucial role in shaping the planet's climate, pulling carbon dioxide from the atmosphere and storing it in their tissues. But this success carried consequences. As these forests expanded during the late Devonian period, they contributed to a dramatic reduction in atmospheric carbon dioxide. At the same time, their root systems altered the chemistry of soils and increased the weathering of rocks, which further drew down carbon dioxide levels. This combination of factors is believed to have contributed to global cooling. Glaciations began to form and sea levels fluctuated. The result was a series of extinction events, including the late Devonian extinction. While often associated with marine life, this event also affected plant communities. Some of the earliest tree-like plants declined or disappeared, unable to adapt to the rapidly changing climate. Scientists believe that shifts in temperature, changes in atmospheric composition, and disruptions to ecosystems all played a role. This was not a sudden, singular moment, but rather a complex and extended period of environmental stress. Still, the outcome was clear. Some of the very plants that had reshaped the Earth were now victims of the changes they helped create. Moving forward into the Carboniferous period, plant life reached new heights, both literally and figuratively. Vast, swampy forests dominated the landscape, filled with towering lycophytes like lepidodendron and sigillaria. These plants could grow over 30 meters tall, with thick trunks and dense canopies. The environment was warm, humid, and rich in oxygen. These forests were so extensive that they eventually gave rise to the coal deposits found today. As plants died and accumulated in swampy environments, they were buried and compressed over millions of years, forming coal. This period represents one of the most significant times of carbon storage in Earth's history. Yet, even this seemingly stable world was not immune to change. Toward the end of the Permian period, the climate began to shift again. Conditions became drier in many regions as continents moved and atmospheric patterns changed. The vast swamps that supported these giant plants began to shrink. Without constant moisture, many of these species could not survive. The collapse of these swamp ecosystems led to the decline and extinction of numerous plant groups. The once dominant lycophyte trees disappeared from many areas, replaced by plants better adapted to drier conditions, such as seed-bearing gymnosperms. This transition marks another moment when environmental change rapidly shaped plant life. The story continues into the Permian period, where further climatic instability brought even more dramatic consequences. The end Permian mass extinction, often described as the most severe extinction event in Earth's history, affected both marine and terrestrial life. Volcanic activity, particularly in the region known as the Siberian Traps, released massive amounts of greenhouse gases into the atmosphere. Temperatures rose sharply, ecosystems collapsed, and many plant species were lost. Fossil evidence suggests that plant communities experienced widespread disruption during this time. Forests disappeared in some regions, replaced by sparse vegetation. Recovery took millions of years, and the composition of plant life changed significantly. One of the key patterns that emerges from these events is that plants are deeply connected to their environment. Changes in climate, atmosphere, and geology can have profound effects on their survival. Even small shifts can cascade into larger disruptions, especially when they occur rapidly. It is also important to recognize that not all extinctions were caused by sudden catastrophes. In many cases, the disappearance of ancient plants was gradual, driven by competition and evolution. As new plant groups emerged with more efficient reproductive strategies or better adaptations, older groups were often pushed out. For example, the rise of flowering plants during the Cretaceous period introduced new dynamics into ecosystems. Angiosperms, with their flowers and fruits, developed complex relationships with pollinators and animals. This allowed them to spread rapidly and occupy a wide range of environments. In doing so, they outcompeted many older plant groups. Some ancient lineages persisted, but others declined and eventually vanished. The fossil record shows a gradual replacement of certain plant communities, reflecting the ongoing process of evolution. Still, there are moments in Earth's history where the disappearance of plants appears more abrupt. Sudden climate shifts, volcanic eruptions, asteroid impacts, and changes in atmospheric chemistry can all create conditions that exceed the tolerance of certain species. The fossil record, while incomplete, provides glimpses into these transitions. Layers of rock reveal changes in plant types, pollen distributions, and chemical signatures. From these clues, scientists reconstruct ancient environments and track the rise and fall of plant groups over time. There is also evidence suggesting that some ancient plants were highly specialized, adapted to very specific conditions. When those conditions changed, even slightly, these plants may have had little ability to adjust. Their extinction, in these cases, could have been relatively swift. In contrast, more adaptable plants, those with broader ecological ranges or more flexible reproductive strategies, were more likely to survive. This pattern continues to shape plant evolution today. The idea that plants can influence their own extinction might seem surprising, but it is a recurring theme in Earth's history. By altering the atmosphere, climate, and soil, plants create feedback loops that can either support or undermine their survival. When these feedbacks reach tipping points, the results can be dramatic. It is also worth considering the role of randomness and chance. Not every extinction has a clear or singular cause. In many cases, multiple factors converge, creating complex scenarios that are difficult to fully untangle. Scientists continue to study these events, using new technologies and methods to uncover deeper insights. What remains clear is that the history of plant life is not a simple, steady progression. It is a story of innovation, expansion, and loss. Some of the oldest plants on Earth were